Inside a concrete dome built to survive a plane crash, a dormant radioactive core is waking up. But it isn't being revived to power 1 million homes, air conditioners, or hospital ventilators. Instead, every single watt of this nuclear giant is being channeled directly into a single massive cluster of silicon microchips. Silicon Valley is running out of juice, and they have just bought a nuclear reactor. For years, the tech industry sold us a beautiful lie: the cloud. It sounded weightless, clean, and completely decoupled from the messy physics of the real world. But under the hood, the modern digital economy is a physical beast. Every search, every generative video, and every synthetic training run demands a flow of real electrons. As frontier AI models scale, their appetite for power is accelerating at an exponential rate. Training a next-generation model no longer requires a server room. It requires a dedicated, medium-sized power grid operating with zero interruptions. This infrastructure crisis became undeniable when Microsoft signed an unprecedented 20-year deal to resurrect a dormant reactor at 3 Mile Island, the site of the worst commercial nuclear accident in American history. Soon after, Amazon paid $650 million to buy a data center campus connected directly to the Susquehanna nuclear plant. Google quickly followed suit, backing a fleet of small modular reactors. These are not standard corporate utility bills. These tech giants are completely bypassing the public electrical grid, buying the power plants themselves. To understand why tech giants are turning to nuclear, imagine the power grid as a giant municipal water reservoir. Wind and solar are like sudden rainstorms. They dump massive amounts of water, but they are highly unpredictable. Sometimes you get a flood, sometimes a drought. But a frontier AI data center is like an industrial drain that must pull a massive, perfectly pressurized stream of water 24 hours a day, 365 days a year. If that pressure drops for even a fraction of a second, a billion-dollar training run instantly crashes. Tech giants cannot run on intermittent weather. They need baseline power, a constant, heavy physical stream of electrons that only nuclear fission can reliably deliver. But the driver behind these multi-billion-dollar deals is not just clean energy public relations. It is a desperate race against a hard physical bottleneck. A landmark 2025 study on the limits of AI growth exposed a brutal truth. We are hitting the ceiling of our physical infrastructure. The line of new factories and developments waiting to connect to the U.S. power grid is thousands of projects deep, with wait times stretching over 5 years. By buying power plants directly, tech companies are performing an infrastructure magic trick called behind-the-meter connection. They are literally cutting the public grid out of the loop, plugging their servers straight into the reactor to jump the line. Many believe that software optimization will save us, that algorithms will become so efficient they will naturally shrink their own carbon footprints. But history tells us the exact opposite. This is Jevons paradox. As technology makes a resource more efficient to use, the cost of using it falls, which causes demand to skyrocket. When AI gets faster and cheaper, developers do not use less computing power. They build models that are 10 times larger and run them millions of times more often. Efficiency does not reduce the physical footprint. It scales it up. This desperate grab for baseline energy creates a dangerous ripple effect. When a tech giant buys up an entire nuclear plant's capacity, they are taking clean, reliable electricity off the public grid. To replace those missing megawatts and keep the lights on in nearby cities, utilities have to spin up older, dirtier fossil fuel plants burning coal and natural gas. The tech companies claim their data centers run on 100% clean nuclear power, but the surrounding communities are left breathing the emissions of the fossil fuels used to replace it. The race to scale artificial intelligence has shifted from a battle of code to a battle of raw physical power. Silicon Valley's ultimate wager is that the profits of artificial general intelligence will justify restructuring the physical infrastructure of our planet. But thermodynamics is an unforgiving regulator. We can optimize code, build faster chips, and write smarter algorithms, but we cannot escape the physical reality of the grid. If the AI bet pays off, it will rewrite global infrastructure. If it fails, we will be left with a hyper-congested, fragile energy system built to chase a digital mirage.